So back into Kaleido, we're going to take a look at our two storage utilities first. So the first one is going to be Document Store, and Document Store is really, really powerful. It has the ability to integrate with existing private storage utilities. So it can integrate directly with your existing AWS S3 buckets or Azure Blob containers, and Kaleido will mirror the existence of those files. They're not going to be persisted onto a Kaleido server, but Kaleido is going to show you the presence of those files. And using our plumbing, using all of that Kafka connection tiers that we have, you can securely submit and transfer these documents to other participants in your network. So this is going to use asymmetric cryptography, sign verify logic, compression, sharding, enveloping. So many things happen under the covers when you transfer a document. But the idea is that it's ultimately going to be encrypted with the counterparty's public certificate, meaning that they will be the only entity in the network that can properly decrypt that payload and make sense of it. It may be interesting for folks if you are intrigued by the architecture and how this works and the asymmetric cryptography, to take a look at the docs and the architecture for Document Store and just get an idea of how many different things are actually happening under the covers. It's quite astonishing how seamlessly it works. But if we look here about all of the asymmetric cryptography, all of the signing, all of the hashing, actually using the counterpart's public certificate to encrypt a symmetric key that actually encrypts the data, and then sending that symmetric key along with those shards and those payloads. It's really quite astonishing. So amazing how simple something can look on the surface, and how complicated it can actually be at the plumbing layer. So I just wanted to give some context for that as I go and show this. It's not as simple as it might seem on the surface, but it's very, very powerful, and it's top of the tier for enterprise security as well. So I've already uploaded a document. This can be anything, right? This could be contracts, this could be certifications, this could be any pertinent private data that is either too large to be referenced on the blockchain or needs to be kept private between a subset of participants. A lot of different flexible implementations of the Document Store service here. One thing also to touch on basically before we actually do a transfer is that those certificates that are going to be used for that asymmetric encryption, those live as key value pairs within our on-chain identity registry. So here we can see our two memberships, organization ABC and organization XYZ, each of whom has a Document Store instance and an inbox or a destination in our nomenclature. And underneath these organizational identities, these X509 certificates, we have key value pairs. So what you're seeing here is you're seeing the destination for ABC for that Document Store, and beneath it is the certificate corresponding to that destination. So what we're going to do is we're actually going to send a document from ABC to XYZ, and what we'll be doing here is we'll be encrypting. We'll actually be encrypting a symmetric key that encrypts the entire payload, but we'll be using this certificate to do that asymmetric encryption right here. This is the counterparty certificate, and he is the only one that has the private key that could do that reverse cryptography. So this is another important piece, another important service that works in tandem with Document Store. It is a prerequisite, it's a mandate. You have to have these certificates. This is the exact same for our app-to-app messaging service as well. So back in the environment, we'll just go ahead and click on ABC instance, and I'm going to upload a new document. Select a file. I'll do another piece of artwork, a Basquiat painting. So we'll upload this guy. And then we can just use this to transfer it. This probably goes without saying, but as I mentioned on the slides, every single piece of functionality in Kaleido, there is either an administrative or service API underneath it. So this can very, very easily be done programmatically. If you go into the Document Store documentation, that's a bit of alliteration there. We actually have a library of code snippets showing you how to do every single thing that you might be concerned with, whether it's uploading, downloading, transfer, or having those socket IO connections to know about, when you have pending deliveries or when something has been sent to you. So this is a very, very useful public-facing GitHub repository perfect for developers or programmers that want to leverage this service here. I see there's a few comments in the chat. I'll grab those here in just a second. So I'm going to go ahead and just use this send button right here. I'm going to choose the counterparty, XYZ. I'm going to choose their destination. I've created one for each, which we saw in the on-chain registry, and I'm just going to send that document. And we'll see an update in real time once it's gone from sent to received, and that acknowledgement has been returned. The verification of that receipt is returned back to this counterparty. Okay, so that is document store at a very, very 101 high level. We can go into XYZ, click on the received folder, and we see the existence, of our Dali painting and the Basquiat painting, which I just sent. We also see the hashes are automatically calculated. So this is the technique where you would reference that hash on the blockchain with the smart contract, maybe along with some metadata, but you're not exposing, that potentially sensitive or private information, or you're not uploading, a huge piece of data that's not suitable for blockchain.